Hello everyone, in this lecture I will solve different problems in motion in one dimension. So let's start here. The position of a particle moving along the x-axis is given by x equal to 21 plus 22 t minus 6t squared, it's in meters, where t in seconds. What is the average velocity during the time interval t equal to 1 and t equal to 3? So let's double check the given information. We have here the position, this one here, x equal to 21 plus 22 t minus 6t squared, and time interval 1 to 3 seconds. The question is find the average velocity. So remember, average velocity, it's equal to delta x over delta t. Now we need to calculate x when t equal to 1. We just substitute 1 instead of t here. So 21 plus 22 minus 6 equal to 37. Now x at t equal to 3, it's equal to, you substitute t by 3. So 21 plus 22 times 3 minus 6 times 3 square, which equal to 33. Now the average velocity in this case here equal to 33 minus 37 divided by delta t, it's 3 minus 1, or equal to minus 2 meter per second. A bullet is fired through a board 14 centimeter thick with its line of motion perpendicular to the face of the board. If it enters with a speed of 450 meters per second and emerges with a speed 220 meters per second, what is the bullet acceleration as it passes through the board? Now let's check the given information here. We have actually a board, this one here, with 14 centimeter thick. Now the bullet enters this board with velocity equal to 450 meters per second and emerges out of this board with velocity equal to 220 meters per second. Now the question is, what is the bullet acceleration through this 14 centimeters? Now let's use equations of motion. V final square equal to the initial square plus 2a delta x, and you solve this one here. The final velocity here, it's 220 square equal to the initial velocity 450 square plus 2a. Now delta x, it's 14. It has to be in meters, by the way, so it's 0.14 minus 0. So you substitute this, you will find that a equal to minus 500 kilometer per second square. The position of a particle moving along the x-axis is given by 6t squared minus 1t cubed, where x it's in meters and t in seconds. What is the position of the particle when it achieves its maximum speed in the positive x direction? Let's check the given information here. We have the position of the particle, it's x here, equal to 6t squared minus 1t cubed. Now the question is, find the position when the particle achieves maximum speed. So maximum will be achieved when the derivative of the velocity equal to 0. So let's derive this one here. So this is v equal to dx by dt, which equal to 12t minus 3t square. Now to find the maximum, so derive v with respect to t and equal with 0. And in this case here, so 12 minus 6t equal to 0, or t in this case equal to 2 seconds. Now you substitute this t back in the position, and x when t equal to 2 equal to, this case here, 6 times 2 square minus 1 times 2 cube, and other words, x equal to 24 minus 8, or it's equal to 16 meters. The velocity of a particle moving along the x-axis is given for t greater than 0 by this one here. Now, where t in seconds, what is the acceleration of the particle when, after t equal to 0, it achieves its maximum displacement in the positive x direction? Now, let's check the given information here. We have actually here the velocity of the particle. It's equal to 32t minus 2t cube. Now, the question asks for the acceleration when the particle achieves its maximum displacement in the positive x direction. So to have a maximum displacement, v of x has to be 0. In this case here, 32t minus 2t cube equal to 0. So in this case, t times 32 minus 2t square equal to 0. It's either t equals 0 or t equal to plus or minus 4. Pay attention here, time will never be negative, so the negative is not acceptable solution. And this one here, it says after t equal to 0, so the only acceptable solution here is t equal to positive 4. Now, a in this case, the acceleration is equal to dv by dt, or 32 minus 6t square. In other words, a equal to 32 minus 96. In other words, a equal to minus 64 meter per second square. The position of a particle as it moves along the x-axis is given by x equal to t cubed minus 3t squared plus 6t. It's in meters, where t in seconds. Where is the particle when it achieves its minimum speed after t equal to 0? dx by dt equal to 3t squared minus 6t plus 6, or in other words, dv by dt equals 0, because it asks for minimum speed. Or in other words, 6t minus 6 equals 0, or t in this case equal to 1 second. Now, the position of the particle when t equal to 1 second equal to 1 minus 3 plus 6, or x equal to 4 meters. The position of a particle as it moves along the x-axis is given by x equal to 15e2 minus 2t, and it's in meters, where t in seconds. What is the acceleration of the particle at t equal to 1 second? Now remember, a, it's equal to dv by dt, and v equal to dx by dt, or in other words, a it's equal to the second derivative of the position with respect to t, and you derive x with respect to t, so it's equal to minus 30 e2 minus 2t, and the second derivative with respect to t equal to 60 e to minus 2t in this case. So a, which equal to the second derivative of x with respect to t square when t equal to 1 second, equal to 60 e to minus 2, and a equal to 8.12 meter per second square. Vx is the velocity of a particle moving along the x-axis as shown in the figure. If x equal to 2 meters and t equal to 1 seconds, what is the position of the particle at t equal to 6 seconds? Now this is not square here. As we can see here in the VT curve here, it's divided into two graphs or two curves, 1 and 2. Now in graph 1, this one here starting from 0, this one here ending up with 3, this case here, and after 3. So let's solve it when t it's less than 3. In this case here, a it's equal to minus 2 meter per second. Now this is the slope of this line here. If we pick up 2 points, this with this for instance, and this with this here, we will find that the slope of this line it's equal to minus 2. And this is actually a linear equation, so v in this case it's equal to minus 2t here plus c. Remember, the y equal to ax plus b. A is the slope, b is the intercept. So this is similar equation as v here. The equation for straight line is this one here. V when t equal to 0, it's equal to 4 from the curve here. When t equal to 0, it's equal to 4 here. And you substitute this, you will find that c equal to 4 meter per second. Now the equation for the velocity here, v equal to minus 2t plus 4. Now to find the position, we have to integrate this v, and x in this case it's equal to integration minus 2t plus 4. Now x after the integration it's equal to minus t square plus 4t plus some constant, let's name it k. Now to find k, let's use the condition here. If x equal to 2 at t equal to 1, now you substitute x equal to 2 and t equal to 1, you will find that 2 equal to minus 1 plus 4 plus k. Or in other words, k equal to minus 1. So the position in the first part of the curve here equal to minus t square plus 4t minus 1. Now x when t equal to 3 equal to 2 meters. Now for the second part, this one here, when t actually is greater than 3, a for this one here, it's equal to 2 over 3 meter per second square. And this is again, this is the slope of this line. Now in this case here, the position x equal to v naught t plus half a t square. You substitute numbers here, you will find minus 2 times 3 plus half 2 over 3, and the time given 3 square. You substitute this minus 6 plus 3 or equal to minus 3 meters. Now the final position here equal to minus 3 for the second part plus 2 for the first part. In total, it's minus 1 meters. A particle moving along the x-axis has a position given by x equal to 24t minus 2t cubed, where t in seconds and x in meters. What is the magnitude of the acceleration of the particle at the instant when the velocity is equal to 0? Now, from the position equation here, let's find the velocity v, which equal to the first derivative of x with respect to time. So v in this case equal to 24 minus 6t squared. And when the velocity equal to 0, so you substitute v equal to 0 and find time. In this case, it's 2 seconds. Now, the acceleration is the first derivative of v with respect to t, and this is the acceleration, and you derive this one here. It's minus 12t equal to a, or in other words, a equal to minus 24 meter per second square. You substitute 2 instead of time in this one here, you will get minus 24 meter per second square. At t equal 0, a particle is located at x equal to 25 meters and has a velocity of 15 meters per second in the positive x direction. Now, the acceleration of the particle varies with time as shown in the figure here. What is the velocity of the particle at t equal to 5 seconds? Now, this is acceleration time curve, and this is linear and it's decreasing. So the linear equation, it looks like y equal to ax plus b, but since the equation is decreasing, so y in this case it's equal to b minus ax. In such a way, a is the slope. So this is acceleration time. So the acceleration in this case, a of t, it's equal to ai minus mt, where m in this case is the slope. Now, to find the slope of this line, you just find tan theta, assuming that this is theta, equal to this here divided by this. So it's equal to 6 over 5. So in other words, the slope of the line, it's equal to 6 over 5. And when t equals 0, ai in this case equal to 6. ai is the intercept, equal to 6. So the acceleration equation here equal to 6 minus 6 over 5 t, and to find the velocity we have to integrate the acceleration. So v of t equal to integration a of t dt, in other words, equal to 6t minus 6 over 5 t squared, and plus c v of t when t equal to 0 equal to 15. Other words, c equal to 15. Now, v of t equation equal to 6t minus 6 over 5 t squared plus 15, or v here when t equal to 5 equal to 30 minus 15 plus 15. In other words, it's equal to plus 30 meter per second. Now, to find the position x of t, you integrate v of t dt, and x in this case equal 6t cubed divided by 2 minus 6 over 30 t cube 6t square, this one here, plus 15t plus d, and x of t when t equals 0 equal to 25, and from this you will get d equal to 25. You substitute now x of t when t equal to 5, you will find it's equal to 150 meters. A particle confined to motion along the x-axis moves with constant acceleration from x equal to 2 to x equal to 8 during 2.5 second time interval. The velocity of the particle at x equal to 8 is equal to 2.8 meters per second. What is the acceleration during this time interval? Now we have here time equal to 2.5 seconds, and delta x it's equal to 8 minus 2 or 6 meters. Now use the equations of motion. V final equal to V initial plus AT, and this is the equation number 1, and V final square equal to V initial square plus 2A times 6. Delta x in this case it's equal to 6, and this is equation number 2. Now V final plus V initial equal to 24 over 5 or 4.8 meter per second. Now when V final equal to 2.8 meter per second is given, now the initial equal to 2 meter per second, and by using equation number 1, this one here, you will find V final equal to V initial plus AT, or 2.8 equal to 2 plus A 2.5 in this case, and the acceleration after all will be equal to 0.8 divided by 2.5, or A equal to 32 meter per second square. A particle moving with constant acceleration has a velocity of 20 centimeter per second when its position is x equal to 10 centimeter. Its position 7 seconds later is x equal to minus 30 centimeter. What is the acceleration of the particle? So let's have a quick sketch here. It's in one dimension here, and the initial position here it's equal to 10 centimeter, and the final position is 30 centimeter, and the time interval it's 7 seconds in this one here, and the initial velocity it's 20 centimeter per second. In this case here, x final equal to x initial plus v initial t plus half a t square minus 30 equal to 10 plus 20 times 7 plus half a, and 7 square it's 49, or in other words minus 180 equal to half a times 49, which equal to, in this case, a equal to minus 7.35 centimeter per second square. In 2 seconds, a particle moving with constant acceleration along the x-axis goes from x equal to 10 to x equal to 50. The velocity at the end of this time interval is 10 meters per second. What is the acceleration of the particle? Now we have a particle moving from x equal to 10 to x equal to 50, and time interval 2 seconds, and the velocity at the end of this time interval it's 10 meters per second. we look for the acceleration of that particle. Again, use equations of motion. X final equal to X initial plus V initial t plus half a t square. Now we need to find the acceleration. Now using this equation here, V final equal to V initial plus at, and from this one here, A equal to V final minus V initial divided by time t. You substitute this acceleration back in this equation here, you will find 50, this is the final position, equal to 10 plus t equal to 2, so 2 V initial plus half. Now the acceleration is this one here, so V final minus V initial over t times t square. So the square goes with this one here, and you will find 40 equal to 2 V initial plus half V final t minus V initial t, or 40 equal to 2 V initial plus 10 minus V initial. In other words, V initial equal to 30 meter per second. You substitute this V initial back in this equation here, so the acceleration after all will be equal to 10 minus 30 divided by 2, or minus 10 meter per second square. An automobile manufacturer claims that its product will, starting from rest, travel 0.4 kilometers in 9 seconds. What is the magnitude of the constant acceleration required to do this? Now let's use the equation of motion. X final equal to X initial plus V initial t plus half a t square. Now the initial position is 0 and the automobile start moving from rest, so this is 0 as well. So X final, which is 400 in this case, equal to, it's 0.4 kilometers, you just convert this into meters, so it's 400 equal to half a times time, it's 9 square, it's 81. You substitute this, you will find that a equal to 800 divided by 81, or in other words, a equal to 9.88 meter per second square. An automobile traveling along a straight road increases its speed from 30 meter per second to 50 meter per second in a distance of 180 meters. If the acceleration is constant, how much time elapses while the auto moves this distance? So from the equations of motion, the final square equal to the initial square plus 2a delta x. So 50 square is the final velocity equal to 30 square is the initial one plus 2a, and the displacement, it's equal to 180 minus 0, it's 180 here, and 2500 equal to 900 plus 360 a, and a in this case it's equal to 4.44 meter per second square. Now to find the time, because it's asked how much time, to find the time in this case here, so V final equal to V initial plus a t, and 50 is the final velocity equal to 30 is the initial velocity plus 4.4, this is the acceleration we got here, times t. You substitute this, you will find t equal to 4.5 seconds. A particle starts from rest at x equal to 0 and moves for 10 seconds with an acceleration of 2 centimeters per second square. For the next 20 seconds, the acceleration of the particle is minus 1 centimeter per second square. What is the position of the particle at the end of this motion? Now let's split this question into two steps. The first step, a particle moving from rest at position equal to 0 and with acceleration equal to 2 centimeter per second square, and the time interval it's 10 seconds. So we have here the first step. The time interval for this step here is equal to 10 seconds, and the acceleration for this in a first part it's 2 centimeter per second square. Now for the second part of the question, in 20 seconds the acceleration become minus 1 centimeter per second square. Now V final here equal to V initial plus AT, and V final in this case it's equal to 20 meter per seconds, because A it's equal to 2 and T equal to 10, so it's 20 meter per second. So X final here equal to X initial plus V initial T plus half A T square. The object starts from origin, X equal to 0, and starts from rest, this is equal to 0 as well. So X final in this case here equal to half 2 times the time interval, in this case it's 10 seconds, so 10 seconds square it's 100. So X final here for the first part of the question it's 100 meters. Now let's find X final for the second part, which equal to X0 plus the initial T plus half A T square. And V initial for the second part is actually the final velocity for the first part. So V initial is the first, it's equal to 20 in this case, so this is 0. And X initial, we just calculated this one here, it's the final position for this, it's the final position for the first part of the question, so it's equal to 100 plus 20. Remember, the initial velocity of the second part is the final velocity for the first part, times 20 plus half, and the acceleration it's minus 1, and time it's 20 square. After all, X final is the final position, it's equal to 100, the first position, plus 400 minus half times 400. After all, the final position equal to 300 centimeters. A rocket initially at rest is fired vertically with an upward acceleration of 10 meters per second square. At an altitude of 0.5 kilometers, the engine of the rocket cuts off. What is the maximum altitude it achieves? Now we have a rocket here, it's fired upward in this direction and with acceleration 10 meters per second square, and it reaches 0.5 kilometers height. After that, the engine of the rocket cuts off, which means after that the object is moving as a free falling object. Now the question is, what's the maximum altitude it achieves? Now to find this one here, Y final equal to Y initial plus the initial T plus half. Now this is A, it's not G, because the first part, T square. Now starting from origin and from rest, so Y final here, it's equal to 0.5 kilometers, so 500 meters equal to half. Now the acceleration for the first part is 10, and the time in this case, it's unknown, it's t squared. So you solve this one here, you will find t equal to 10 seconds. Now v final for the first part, it's equal to v initial plus a t, or in other words, this is 0 and a equal to 10 meter per second square, t it's equal to 10, so v final equal to 10 times 10 or 100 meter per second. Now the final velocity of the first part is actually the initial velocity of the second part of the trip. So in this case, v final equal to v initial minus gt. And remember, the second part is free falling object, and the acceleration for this one here, it's equal to minus 10. Now v final, it's equal to 0 because it's mentioned that the maximum altitude in this case here, this one here, so this one here equal to 0. The initial for the second trip is actually the final for the first trip. So in this case, 100 equal to 10t, or t in the second part equal to 10 seconds. Again, y final equal to y initial plus the initial t minus half g t square. Now this is g, not a like in the first part, so it's equal to y initial, it's 500 plus 1000, it's 100, the initial times t, 10, it's 1000 minus 10, g equal to 10 and t equal to 10 square, it's 100. You substitute this, you will find y final equal to 1000 meters. A ball is thrown vertically upward with an initial speed 20 meters per second. 2 seconds later, a stone is thrown vertically from the same initial height as the ball with an initial speed 24 meters per second. At what height above the release point will the ball and the stone pass each other? So the situation is as this. We have a ball is fired upward, this one here, with initial velocity equal to 20 meters per second. Now 2 seconds later, a rock is thrown, here is rock, is thrown upward with initial velocity 24 meters per second. Now at what height above the release point will the ball and stone pass each other? The simple answer for this situation here is when the ball and the stone both have the same height. So let's calculate the height for the stone and the height for the ball as well and see. So y for the ball equal to the initial t, and remember y initial is actually equal to 0 minus half gt square, or in other words 20t minus half gt square. So this, let's name it equation number 1. Now for the stone, y for the stone equal to, again, the initial position, it's equal to 0, so the initial t minus half gt square, or 24. Now t in this case, it's t minus 2, because after 2 seconds the stone starts to move. So 24t minus 2 minus half g t minus 2 square, and this is equation number 2. Y for the ball equal to y for the stone. They will catch up each other, or they will pass each other. In this case here, 20t minus half g t square equal to 24t minus 48 minus 5t square plus 20t minus 20. You simplify this one here, so 24t equal to 68, or t in this case equal to 2.83 seconds. Now y, now it doesn't matter actually for yb or y stone, anyone will be good. So yb equal to 56.6 minus 40.04. You just substitute time in equation, this one here, and you will get 17 meters. An object is thrown vertically and has an upward velocity of 18 meters per second. When it reaches 1/4 of its maximum height above its launch point, what is the initial launch speed of the object? Now here's the situation. An object is thrown vertically, this one here, and when the velocity equal to 18 meters per second here, the height will be 1/4 of the maximum height. Now the question is, what's the initial velocity? So v final, again equations of motion, equal to v initial square minus 2g h over 4. So 324 18 square equal to the initial square, which is unknown here, minus 5h. Now let's keep this equation here. Now v final equal to v initial minus gt, and from this case here, t equal to v initial over 10. Now the maximum height equal to v initial t minus half gt square, or the maximum height h equal to the initial square divided by 10 minus 5 the initial square divided by 100. In other words, it's equal to h here equal to the initial square over 20. Now you substitute this h here back in this equation here, you will find 324 equal to the initial square minus 5 the initial square over 20, or 324 equal to 3 over 4 the initial square. In other words, the initial equal to 21 meters. An object is thrown downward with an initial speed of 10 meters per second from height of 60 meters above the ground. At the same instant, t equals 0, a second object is propelled vertically upward from ground level with a speed of 40 meters per second. At what height above the ground will the two objects pass each other? Here's the situation. We have an object thrown vertically downward here with initial velocity 10 meters per second from height equal to 60 meters, and this is the ground here. Another object, this one here, is thrown vertically with initial velocity 40 meters per second, in this case here. Now the question is, at what height above the ground will both objects will pass each other? Now same situation as before here. When both objects have the same height, they will pass each other. So y final for object 1 equal to y initial plus the initial t minus half gt square, and y final equal to 60 plus 10t minus 5t square. Now for the other part, y final equal to the initial t minus 5t square, or 40t equal to 60 minus 10t. So 50t equal to 60, and from this one t will be equal to 6 over 5, and after all, y final equal to 40 times 6 over 5 minus 5 over 6 over 5 square, and 48 minus 7.2, almost 41 meters. A toy rocket launched from the ground rises vertically with an acceleration of 20 meters per second square for 6 seconds until its motor stops. Disregarding any air resistance, what is the maximum height above the ground will the rocket achieve? To have maximum height, remember that velocity up there equal to 0, so y final equal to y initial plus the initial t plus half a t square. Now it's a, it's not g, because it's not free falling object. So equal to, starting from origin and starting from rest, both will be 0, 0, half the acceleration, it's 20, and the time in this case it's 6 seconds, so 6 squared is 36. So y final equal to 360 meters. Now v final equal to the initial plus at, and the initial in this case equal to 20 times 6, and the initial in this case equal to 0, so the final in this case it's equal to 20 times 6, or equal to 120 meter per second. Now v square final equal to the initial square minus 2g delta y. This is for the second part. Now this one is equal to 0, and the initial for the second part of motion is the final for the first part. So 120 square minus 2. Now this is free falling, by the way. 10 y maximum minus y initial, so 120 square minus 20 y maximum minus 360. To simplify this one here, you will find y equal to 21,600 over 20, or y equal to 1.1 kilometers. A ball thrown vertically from ground level is caught 3 seconds later by a person on a balcony which is 14 meters above the ground. Determine the initial speed of the ball. So we have a ball is thrown vertically upward in this one here, and a balcony or a person on a balcony with a height 14 meters caught this ball after actually 3 seconds. The question is, what is the initial speed of the ball? Now y final, this one here, equal to y initial plus the initial t minus half gt square. 14 is the final position, equal to 0 is the initial position, its origin, 3 the initial minus 5, and t in this case 3 seconds square, it's 9. You substitute this, you will find the initial equal to 59.3, or in other words, the initial equal to 19.7 meter per second. An object is thrown vertically upward such that it has a speed of 25 meters per second. when it reaches 2/3 of its maximum height above the launch point. Determine this maximum height. Now here's the situation. An object is thrown vertically upward here, and the velocity reaches 25 meters per second when the height of the object equal to 2/3 of its maximum height. How much the maximum height? Now let's solve this one here. The final square equal to the initial square minus 2g delta y, and 25 square equal to, now we need to find the initial in this case here. On the side here, v final equal to v initial minus 2g delta y, this square, this one here, and from this one here for the second part, I'm talking here about the second part, so the initial equal to square root of 2g delta y. You substitute this back in the first part of the motion, so this one will be 2g. Actually, no need to say delta y because the initial position equal to 0, so just y minus 2g 2/3 y, and 625 equal to 2g y times 1 minus 2/3. Other words, 625 equal to 20 y times 1/3, or y in this case equal to 94 meters. A car travels north at 30 meters per second for 1/2 hour. It then travels south at 40 meters per second for 15 minutes. The total distance the car has traveled and its displacement are. Let's draw the situation. A car is traveling north, like here, with velocity equal to 30 meters per second for half an hour, so 30 minutes. Now then travels south at 40 meters per second for 15 minutes, so travels south here for 15 minutes with velocity equal to 40 meters per second. Now to find, or the question is, what is the total distance and how much the displacement? Now to find the total distance, y equal to y initial plus the initial t plus half a t square. Now it's constant velocity, this is 0 now, and starting from origin this is 0 as well. So for this one here, the initial equal to 30 times 30 minutes times 60 seconds, and in total y equal to 54,000 meters. Now y for the second part equal to, same rule, it's 40 times 15 times 60, so it's equal to 36 y, and this is y1, this is y2, 36,000 meters. Y total equal to y1 plus y2. This is the total distance, which equal to 90,000 meters or 90 kilometers. Now delta y in this case, it's equal to 18,000 minus 0, because it moves here 54, then back 36. So this is the new position here, it's 18,000, and the initial position here, it's equal to 0. So 18,000 minus 0, so it's equal to 18 kilometers, and directed north. A skier leaves a jump with horizontal velocity of 29.4 meters per second. The instant before she lands, 3 seconds later, the magnitude of the horizontal and vertical components of her velocity are. So we need to calculate the magnitude of the horizontal and vertical components of her velocity. This is the ramp here, and the skier leaves the track horizontally with velocity 29.4, and after 3 seconds the skier will be somewhere here and in position X and Y. So what we need to calculate here is the position X and Y. So the initial horizontal velocity of this skier is 29.4 meter per second. Since this is like a projectile motion, and in projectiles ax in this case equal to 0, which means the velocity on x is constant all the way on the whole trip. So in this case, v final is actually equal to vx initial, or 29.4 meter per second. A bicyclist starts downhill with an initial speed of 2 meters per second. She moves down the hill with a constant acceleration, arriving at the bottom of the hill with speed of 8 meters per second. If the hill is 12 meters long, how long did it take the bicyclist to travel down the hill? So here's the situation. We have here a hill like this one here, and here's the bicyclist, and traveling down this one here with 2 meters per second, the velocity here, or the ramp length here is 12 meters, and the velocity of this bicyclist is 8 meters per second. Now we need to find the time it takes the bicyclists to travel down the hill. Now v final, equations of motion, square equal to v initial square plus 2a delta y. Now this is 64. This is the final velocity equal to initial velocity. It's 2 square, it's 4 plus 2a times delta y. It's 12. The length of the path or the track, it's 12 meters. From this we can find a equal to 2.5 meter per second square. Now v final equal to the initial plus at, or in other words, the final it's 8 equal to 2 plus 2.5 times t. You do this, find t equal to 2.4 seconds. A helicopter descends from a height of 600 meters with uniform negative acceleration, reaching the ground at rest in 5 minutes. Determine the acceleration of the helicopter and determine the acceleration of the helicopter and its initial downward velocity. So here's the situation. This is the helicopter descends down with negative acceleration from height 600 meters and reaches the ground here at rest in 5 minutes. Now we need to calculate the acceleration of the helicopter and its initial downward velocity. Now for this one here, v final equal to v initial plus at, or in other words, the initial equal to a times 300, and don't forget the minus sign here because the final velocity is equal to 0. Now v final square equal to the initial square plus 2a delta y, and this is equal to 0 as well. So the initial square minus 2a delta y, it's 600, because it's 0 minus 600, it's minus 600 equal to 0, and in this case here Now you substitute the initial, this one, back in this one here, and you will get a square times 90,000 plus 12,000 a equal to 0. In other words, a times 90,000 plus this one here, 12,000 equal to 0. So a equals 0, which is not acceptable in this case here, or a equal to minus 0.0133 meter per second square. V in this case equal to minus a times 300, or minus a in this case it's minus 0.0133 times 300, or in other words, V equal to 4 meter per second. A car originally traveling at 30 meters per second manages to brake for 5 seconds while traveling 125 meters downhill. At that point, the brakes fail. After an additional 5 seconds, it travels an additional 150 meters down the hill. What was the acceleration of the car after the brakes failed? So the situation is as this. We have here a car traveling down the hill here, and with initial velocity 30 meters per second. Now it moves 125 meters down the hill. Now at that point, no brakes, catches up. Now after an additional 5 seconds, it travels an additional 150 meters down the hill. The question is, what is the acceleration? So we need here to calculate the acceleration before the brake fail. Now x here equal to the final plus the initial over 2 times t, or in other words, for the first part, 125 equal to v plus 30, this is v final, 30 over 2 times 5, and in this case, v final for the first part equal to 20 meter per second. Now v before the brakes fails equal v after the brake fails, which means in simple words, v final for the first stage is the v initial for the second stage. In this case, x equal to the initial t plus half a t square. You substitute the numbers from the second part, 150 equal to 25 plus half a 5 squared, 25. In other words, the acceleration equal to 4 meter per second square. A peregrine falcon dives at a pigeon. The falcon starts with 0 downward velocity and falls with the acceleration of gravity. If the pigeon is 76 meters below the initial height of the falcon, how long does it take the falcon to intercept the pigeon? So here's the situation. The pigeon here is 76 meters below the height of this falcon. So this is the falcon and this is the pigeon. The distance between them is 76 meters, and the falcon dives free falling with acceleration of gravity 9 meters per second square. In this case here, how long does it take the falcon to catch division. Now y final in this case equal to y initial plus the initial t minus half gt square, and starting from rest, it's mentioned right here, and 76 with minus because it's below the reference point equal to minus half 10 t square, and 0 by the way, and you will find that t equal to 4 seconds. That's it. Thank you for watching.